Hello everyone, today we're going to go over how to create a scene such as the one you're seeing on screen. We'll be building upon the tutorials where we did the landscape outer material and where we used the foliage tool and optimized foliage so it performs well. The first thing we need to get started with our PCG project is going to edit, plugins, type PCG and enable the Procedural Content Generation framework. Once you enable it, you'll have to restart your project or restart the engine. Once you do so, it's time to choose the assets you want to use. In my case, I'm choosing 3 of the trees that we created in a previous tutorial using the modeling tool. Well, we didn't create them, but we did variations from a single asset. Then from the same pack that we used in the last tutorial, we're getting the rocks, a small pine tree, fern, grasses, and some rocks and different plants. As you can see around the landscape, I've also placed a few rocks just to give it a bit more variety. These rocks will have to be excluded from the PCG graph, meaning that I don't want any grass or trees to spawn inside the rock, same as this house. So the way we can accomplish this is in 2 ways. As you can see, I have a volume around the house. We can exclude the volume from spawning any points with our PCG graphs, and we also can exclude actors. So once you have all those things done, the first thing we're going to do is create a volume. So in case in your map you want to put houses on this part of the square, you can create a big volume, and that way the PCG won't generate any points there or trees or such. So we can go here to basic, we simply type volume and we look for blocking volume, and for the PCG to identify this volume we're going to have to give it a tag. So in the details panels we can type tag, and below the actor we can add a new element, and I'm gonna call it exclude. Make sure you always use this name and that every volume has this tag, the exact same spelling and everything, and place them on your map wherever you want. The next thing we're going to create, we're going to delete the volume, are the actors that we want to exclude. So I created a small folder where I am going to explain the PCG graph, and I also made a little folder where I have the actors that I want to exclude. And what I created here was a blueprint class of type actor. I named it environment actor, and inside this blueprint, I simply added a static mesh that, if we go to the viewport, is simply one of these rocks. And from this blueprint I created 3 childs with different rocks, and these are the actors that I've been placing all around the landscape. Once you've placed your actors around the world, we can then proceed with our PCG graph. So to create one of these, we can go down here, PCG graph. I already have mine, so I won't create another one. And to get started, I'm gonna place it somewhere where we can see all the filters being applied. So I'm gonna increase this to 40, and this to 50. Okay. We can close the environment actor. We can go into our PCG graph. So once you open it, you'll have these 2 nodes here, we're not going to use them, so just ignore them for now. I'm going to actually unplug this so we don't see the trees just yet. And the first things we want to do in our PCG graph is get landscape data, since we're going to be using this information in basically all the graph. So simply type get landscape data. And from here I created a reroute node, which I use at the beginning of all these lines of code to create reroute nodes, which we'll be using a lot in this project. You simply drag from the pin, type reroute, and add named reroute declaration node. You can right click it, rename it to whatever you want, and then if you want to get a reference to it, you simply type the name of the reroute node. Sorry, not this one. And here we have it. Okay, so once we have this, our landscape data, we want to get our exclusion actors. First we will get the volume, so get volume data. And now the PCG needs a way to identify which volumes you're talking about. So on actor filter, we say old world actors by tag, and we type the tag that they had. In my case it was exclude. So we type exclude and make sure you click on select multiple, so it selects all world actors with this tag. For the get actor data, it's really similar. Get actor data, with it selected, we go here, all world actors by class this time, and we're going to type the name of the parent blueprint. So environment actor, and then again select multiple. Once we have our get volume and get actor data, we need a volume sampler, so we simply drag volume sampler, and this will generate points around the mesh or the volume to tell the PCG graph that they should not spawn any trees or grass or anything inside that actor. Then we created two reroute declaration nodes, and if you actually want to see what this does, and we go to get actor data and we click on debug or D on your keyboard, we should see, or not, connection. I don't know why I'm having problems with the debug today. Let's see if this one works. Also doesn't work. Well, as you can see, you'll just have to trust me, I guess. Here, I'll explain this in detail, but basically we're getting the points generated by these volume samplers, and we're applying a difference, a binary difference, from the points where we want the trees to be and these ones. So as you can see, the trees don't spawn anywhere on the rock. Okay, I simply restarted the project and now it seems to work. So basically what I wanted to show you before we had the problem was that if I go to get actor data and I click debug, you can see that the rocks are generating points where the PCG graph won't appear. And that's what the volume sampler does. So once we have our landscape data and our volume and actor data, we can proceed with this part of the code. I'm working from big to small. So we're first going to do the trees, then the rocks, then the fern and sapling points, then the debris points, and then the grass points. Most of this code is just copy paste, so once I explain the top part, you'll be able to understand the rest. I'll go over it really quick and then we'll go back one by one. So from the get landscape layer, we're getting the surface sampler. Then we're filtering, so the trees are only painted on the grass layer. Then we're subtracting points from exclusion actors, meaning that the trees won't spawn either on the exclusion actor that we got here or the exclusion volume that we get here. Then we're going to eliminate points that are too close to each other. We use the distance, so points that are in a maximum distance of 550 will be eliminated using the density filter. And then we eliminate points on steep slopes. We add variation to the points, so each tree has a different rotation and such. And then we simply spawn the static mesh. So let's go one by one. The surface sampler. This would be all the points that are generated by the surface sampler. In here, there are a few options that you might want to touch. One is the point extents, which should cover more or less what the mesh is going to be. That's why they are narrow and long, more or less like trees. And then we've also increased the looseness. By default, a surface sampler will have a default value of 1. I increased the looseness so they are a bit more spread out. Okay, we can unclick the debug. Next thing is an attribute filter. If we go again to the surface sampler and click on A on your keyboard and go down here, we'll see all the data it's collecting from your landscape, including the layers of your landscape. So if I go to landscape, I go to the selection mode, landscape mode, paint, I can see the layers I painted. So I have my main, blend and path. I do not want the trees to appear on the path layer, which is this brownish one you see here. Go back to my selection, I go to the PCG and I type attribute filter. Sorry. Operator we can leave default, and in target attribute we're going to type the exact same name that appears here. So it would be path with a capital P, as you can see here. Then we proceed out of this layer, so out of the path, we create a difference node. In density function, we're going to put binary. The source is going to be the points that we want to generate, so in this case the trees, and the difference is going to be the exclusion actor and the exclusion volume. So if we click debug here and we go back, you'll see that the points are now generated only on the grass layer and nowhere on the rock. Then we continue and we create a distance node. In this case, we're just subtracting the trees from the trees, so they're not too close together. But later on, we'll use the same node to to subtract the points that we want from our rocks, not to be too close to our tree points. But we'll get later to this. After a distance, we need a density filter. This will control. Let's actually press debug there. This will control how many trees are eliminated if they are not within this distance. So we can decrease this to get more trees and more trees. But I wanted all the trees that were too close to each other to be eliminated, so the lower bound I increased to 1. After eliminating the points that are too close to each other, we want to eliminate points on steep slopes. So I don't want the trees to appear on the rock. So what we do is a normal to density. Here all the values are left by default, I believe, yeah. And then we apply another density filter. And here I have an approximate value of 7.8. If we debug this also, and we change these numbers, you can see that now more and more trees start appearing on the cliffs, or at least the points that were on the cliffs beforehand. But I also don't want them to be, so let's go to 0.78, back to where we were. Once we have all our filters done, so we're filtering by landscape layer, by where our actors and volumes are placed, whether or not the trees are too close to each other, and then the steep slopes, we're going to add variation to the points. And for this we use a transform point node. In here we have a series of values. And as you can see, we have an offset min and offset mat. So is the tree going to be spawned below or a bit high above the landscape? In my case, I wanted them to be a bit below, just in case a tree is placed here that you don't see the underneath it. Then we want the tree to be able to rotate 360 degrees in all directions. So I simply left rotation min at 0 and this at 360, or you could put minus 180 and 180, whatever you want. And I did want the trees to tilt a bit, so I added a 10-degree angle of space. We want to mark absolute rotation, so they are always vertical, independently of how the slope is. But we will take this option off for grass, for example. And then I also want to set a range in scale. So I want trees to be able to be their default size and a bit larger. And once we have all that done, I added another reroute node here and named it tree points, because we'll be using the points generated here as subtraction for other meshes. As you can see here, here, here. So it's just handy to have. And then to finally spawn your trees, let's make sure we don't have any debug thing enabled. We need a static mesh spawner. Inside this static mesh spawner, we're gonna go here into mesh entries, and you're gonna add as many meshes as you want. As we said at the beginning of the video, we're using these 3, so we're only adding 3. Descriptor, here's where you put your mesh. And here are all the options that we covered in our foliage optimization video. So let's go over the most important ones. First one is evaluate world position offset. So if it has wind, ticking this means that the wind will affect the mesh. Then we also want to set a distance to disable the wind. So in this case I set the distance to be 6,000. I also made the shadow cache invalidation behavior static, since it's much more performant than auto or always, and you don't really notice the shadows that much. That's just something that you're gonna have to try out. And then actually we went over it. here. The co-distances. I don't want any co-distances from my trees since I want them to be seen from a far distance. So I left them at 0. But for other meshes, which we'll go over later on, I did change these numbers. Another thing that's also interesting to note is was it here or? Yeah. So this weight means how much importance does the PCG give to this particular mesh. As you can see, the weight of these is the same, which means that they will be spawned with the same frequency. If you change these numbers, you might prioritize one tree over another. You can also play with that in case you want trees that you like more or less or something like this. So once we actually plug this back in, we should see our trees spawn inside our PCG volume. And here they are. The next thing we want to spawn are the rocks. These small rocks. So this is gonna be the same. Actually, let me just plug this back in. Break, put this back. And I want to break the other ones because we don't want to see them just yet. Okay. Here we've done the same. Surface sampler with different point extents. Since the rocks are going to be a bit bigger, we can actually decrease the height of these, which we should have done. And as you can see, these are the first points that are produced. Then we have the attribute filter, which is the same thing we had here. Then we have a difference. And we have the exclusion and the volume, so the same thing here. And then we have a distance node, but this time instead of subtracting from each other, we're subtracting from the trees, since we don't want the rocks to be too close to the trees. And the maximum distance I put here was also 550. And the density for this, I left at 1, And then we want to do some random exclusion. So if we debug this, you'll see that it's giving a different tone of color with a random spatial noise. To change the noise, in case you want to use this node further on, we can always go to transform and change these numbers. If I change this to be, actually let me just go here. As you can see, it changed. Let me just put it back where it was. The randomness will change. We also use a density filter. This time I think I have it to 0.5. And then we have normal to density, since we also don't want a lot of rocks on the hills. But this time, yeah, we're not eliminating all of them. So we're only eliminating 0.83. And the final step is again transform points. Here we have a bigger offset min, since we covered in a previous video the runtime virtual textures, meaning that if the rock is deep into the landscape will actually blend with the rock. So I did want to showcase a bit of that. So I decreased the offset min to -100. Then we do the same. We don't promote it. We add a reroute declaration node and static mesh spawner. Here we added the 2 rocks. And as you can see for this one, we did add a cool distance of 15,000, the start cool distance and the end cool distance of 20,000. Since it's a rock, we're not gonna enable evaluate world position offset, shadow cache invalidator we have on auto, although we could put on static since it doesn't really matter. The rock is not going to move. And we're going to do the same for the second one. And that would be the rocks done. As you can see, we're reusing a lot of these nodes to exclude the rocks from the trees, and it's what we're going to continue to do on now. The next step will be the fern and the sapling points. So these two meshes, since they are more or less of the same size, so before I plug it in, same thing here, surface sampler with different numbers. You can also reduce this. I'll probably have to reduce it here, yeah. Attribute filter, we don't want them growing on the path layer. A difference to exclude the exclusion actor and the exclusion volume. Then we have a distance. This time we're including also the rock points that we created here. So we're including the tree points and the rock points. Applying a density filter. Spatial noise again, but this time we will have different numbers here. As you can see, we have 5,000, 5,000. Then also a normal to density to exclude slope. Transform points again. These are the sapling, and here are the ferns. And as you can see, for the ferns and the transform points, I don't have the absolute rotation, because if I connect this, I want the ferns to be exactly perpendicular to the terrain. While the pine trees and the small pine trees, I want them to be always vertical, more or less. As you can see, this is what I was talking about. I should actually, if I go back to my trees, transform points, we could reduce this to 15 and this to 20, and that should fix it, I think. Not yet. Let's put 25 and here 20. Okay, good enough. And we did the exact same thing for the ferns. So this is the pine trees, the small pine trees. As you can see in the distance, we also included the sapling points, which are the ones we create here. The order in which you do these doesn't really matter. As long as you have a reference to the points that you created for this particular mesh. And within these options, we do have co-distances. This one is a bit lower than the rocks. We are evaluating the world position offset, but we're disabling it at 4,000 units of distance. And the shadow is again static, since it's more performant. I think here we're disabling at 3,000, since the ferns you won't notice as much. Static again with the shadow. Evaluating world position, and I think the co-distance is more or less the same. Next thing we're gonna go over, and here's where we complicated things a bit more. I mean, it's still easy, but just we add a few more things. Is that with the debris points, meaning the small rocks and the cloves, we still want to place them inside the path, but with not as much frequency. So what we actually do is still always start with the surface sampler, and then we apply the attribute filter. We would normally go outside the filter, but this time inside the filter also. This part is exactly the same. We apply the difference. Again, the same distance from the points we don't want. So now we're including the tree points, rock, sapling, and the fern points. Applying density, filter, spatial noise. But this, I think, yeah. Since we are differentiating between the attribute filter, between the layers of the landscape, sorry, we want it to be a bit more frequent. So debris, we want there to be more meshes in the path layer than outside the path layer, which is why the filter, the density filter here is 0.4 and here 0.52. Then again we have the normal to density, since we don't want it to spawn on slopes, and we have the transform, which is the same in both. For these ones, we also have a start and end co-distance. This could be lower since they are small objects that the player is not going to see until he's really close to it. So again, these numbers are up to you and how well you want to increase performance. And then we have world position offset, although yeah, we're not even evaluating world position offsets, and those two assets are not going to be moving. Shallow cache invalidation behaviors on auto, although it doesn't really matter since there's no world position offset. We can place it to static. Again, these options I cover in another video, but it's quite simple. And we should have our debris placed now. As you can see, we have it around the grass areas and also on our path. At least as long as the volume. The next thing is the grass. Same thing here. We're gonna differentiate based on the layer. So if it's inside the path layer or outside. Same thing here, surface sampler, attribute filter, then the difference between the exclusion actor and the exclusion volume, so it doesn't appear on rocks or something like this. Then the distance. Here I have two distance nodes because I wanted the distance between the debris points and the grass to be different from the distance to the trees. So here I have a distance of 150 and here I have a distance of 100, since I want the grass to be closer to these type of points. 150, here I think the distance is a bit lower, 300. We started with a distance of 550 up here, and we have slowly been decreasing the distance the smaller the meshes are. Okay, debris points, density filter, spatial noise, and I think this is the density filter that differentiates itself, yeah. So this number is higher than this one. Normal to density again, transform points. Yeah, and when you have two different meshes spawning, but the points you want to collect into one, you use this merge points. And from here, we're using the reroute declaration node. So we only have one of these instead of one for this line and one for this line. And we should see the grass spawn now. As you can see, the density of the grass on the path is lower than on the grass layer. And finally, we want to add the flowers. Which is more of the same. Surface sampler, attribute filter. This time we want no flowers on the path. The difference for the exclusion actor and the exclusion volume. Then the distance to the tree points, rock points, sapling points, and fern points. We want a different distance of 70 for the debris points and the grass points. Another spatial noise density filter. This is just to give a bit of randomness, and it creates these open spaces. Then the normal to density again, transform points, and the static mesh spawn. And that would be all in the PCG graph. Okay, so once we've created our PCG graph as we want, we can select our volume. Actually, I want to show you one mistake I encountered the other day. Right now, as you can see, inside the rock, there's nothing spawning. But this wasn't the case when I first started with this project. If I go back to my, I think it's this one. I'm going to open the mesh. And if I go to my collision settings, it was set to, I believe it was simple and complex. And now if I nope, use simple collision as first, it was this one. I use complex collision. I guess it's always the last option, isn't it? Okay. So as you can see, if the mesh is set to use complex collision as simple, this might happen. And I spent a lot of time wondering why this was happening until I found that solution. So just in case you come across the same problem and the PCG is not excluding your actors as it should, it might be due to the collision complexity option. So make sure it's by project default or simple and complex, or use simple collision as complex. And now if we move the rock, we should no longer have that problem. Okay, so once you've solved all your problems, you have your PCG graph and everything, we can click on the PCG volume, we can go into the details panel and type cleanup, and then we're gonna set the PCG volume to the dimensions of my landscape, which if I remember correctly was 250, 250, and this was 60, and then I want it to be in the center. And I think that should cover everything, and yes it does. Once you've covered the whole of your landscape, we can click generate. This will take a while probably. Another suggestion is that if you're going to make any changes to your PCG graph, make sure that the volume is a little one, because every time you make a change, this will update and it might crash your Unreal Engine unless you have a great PC. And as you can see, everything is as we set it out to be. And right now I'm getting around 100 FPS. So even though it's quite foliage heavy, the optimization options that we selected work quite well. Although if you see closely, you can see when the trees start with the wind and when they are turned off. So you might want to tweak those options. And if we go out and we look inside our rocks, we shouldn't have any plants here. We should also don't have any plants around this volume, which as you can see, it's correct. And also here. Okay, one more thing I forgot to mention is that once you're happy with your PCG volume, instead of having it as a PCG volume, you can actually come to these options and clear PCG link. And now if we move our volume, it no longer updates. And we've created a PCG stamp. And that was all for today. I hope you enjoyed it. I hope you learned something and you found it useful. And if you did, don't forget to like and subscribe. I'll see you in the next one.